Okay. Right. Can I get rid of these? So these are your first 5 laws. So let's do the 6th one. So we know to use all these laws, your bases have to be the same. Okay? If they're not the same, you can change one of the bases by using this change of base law. Okay? So now it is given to you, okay, it is given to you in the log tables, but if you want, we can put words in it to make it easier to remember. So if you have log to the base a of x and you want to change it to be your new base, which is log to the base b, okay, you're going to do log of the new base and the old value over log of the new base and the old base. Okay, so log the new base, old value, over log new base, old base. Now you don't have to learn the words, because you can just go straight to your log tables and actually use it. Yes, so you'll have numbers in this.
What would you put in for new base?
Whatever you want to change it to. So if I have a question, and I'll do it in a second, but if I have a question with log to the base 2 and log to the base 3, I can either change this one to be a 3 using this, or I can change this one to be a 2 using this. And it doesn't matter which one you change to. Okay? So you have a new base that you've chosen, and then you have the old base and the old value that they gave you. Okay? So I will do that in a sec. Okay, now a few important things just before we go. If you are given a question and it just has log and no base, okay, you can assume that the bases are the same. If they don't tell you a base, you can assume they're the same. So that'll come up in a minute, and again, I'll notify you when we're doing that. Okay. If you have log to the base 10, that's called common logs. Okay. Now these used to be really important when we didn't have calculators who'd do logs to any bases for us. Okay. Now our calculators do it all. But log to the base 10 is common logs, and log to the base e is called natural logs. Now e is just a number, okay? Similar enough to the way pi is an approximation for 3.14 e is an approximation for 2.718. Okay? Log to the base e, just a little note, let's just write this here somewhere. Log to the base e, or ln. Okay? Same thing. ln of x, or log to the base e of x. Okay, so if you see ln, it just means log to the base e. These are called natural logs. And they used to be used for things that occur naturally. Earthquakes, growth of bacteria or colonies. Okay? Log to the base e, or ln. Now, we're going to use this a lot in the next few days. Okay, so it will become a little bit clearer. Will we do a few examples of working with the laws before we get into this thing? Yeah? Okay. Can I get rid of the board? So 2 log to the base 10 of 3 plus log to the base 10 of 16 minus 2 log to the base 10 of that.
Katie O'Halloran and Patrick want to reception now.
You're just going to apply a few of the rules, okay? So see whichever ones come at you first. So 2 log to the base 10 of 3. Where did that 2 come from? Yeah? That's, yeah, 2 by this log here. Where have you seen that law where there's a number in front? And where did that number in front come from? Yeah. Okay, so that 2 came from up there as a power, didn't it? So it's log to the base 10 of 3 squared. We said if you have a power, it can come down in front, and vice versa. Plus log to the base 10 of 16, can't really do anything there. Minus, what about this? Same thing. The 6 over 5 to b squared. So, log to the base 10 of 9, log to the base 10 of 16, minus log to the base 10 of 36 over 25. Now, everyone alright with that? Okay. I'm adding 2 logs and the bases are the same. What do I do with them? Multiply, lovely. And I'm minusing 2 bases that are the same. Divide, lovely. So log to the base 10 of 9 by 16, whatever that is, over 36 over 25. Okay? Because I'm dividing. So when I'm minusing, my law tells me that I need to divide this divided by this. Now,
does the 36 over 25 go over the log to the base 10 as well?
what? Say that again?
Is the 36 over 25, is that all
No.
under log?
No, it's just this part of it. Okay?
That's the value.
Yeah. Now what I get is 144 divided by 36 over 25. Yeah? 9 16s is 144, isn't it? And I'm dividing that by 36 over 25. How do I divide? Turn it upside down and multiply. Because we're dealing with numbers, I can actually just throw that straight into my calculator. And I get 100. Log to the base 10 of 100. Log to the base 10 of 100. No. Come back to me here. Log to the base 10 of 100. There's my base. Here's my power. Here's my value. 10 to the power what gives me 100? So my answer is 2. And you can just throw that into your calculator if you want to check. Log to the base 10 of 100 is 2. You could be given some, yeah, to simplify with x's, yeah, or a's and b's.
On this, does the first one always go on top of the fraction and the other one?
This, yes, this always goes on top and this always goes on the bottom. Yeah. We do another one?
Yeah.
Okay. Can I get rid of this? What example was that, sorry? Oh, great. Okay. So we were saying we can only use our laws when the bases are the same. Okay? Now I can either change them to get all the bases the same, okay, or because these are all numbers I could figure out what that is. I'm just going to change them all so that the bases are the same, okay. So what bases am I going to use? What base? 3. I'm going to change this to be a base of 3, okay, because they're already 3. So if I want to change this, I go back to my formula, and what we said was, give me my words, log new base, old value, new base, old base. Okay. So, I'm changing this to be log to the base 3 of the old. This is probably prolonging things. It might be making things a bit. Anyway, we'll do it. New base old value 128 over log new base old base. Okay, this is prolonging things, but anyway. Okay. Yeah, this isn't going to help us much for what I wanted there. It's actually going to make things more difficult for us. It might be easier to actually just figure out what this is. Yeah. Okay. If we were to do it this way, will I keep going with this way? Yeah. Okay. Log to the base 3 of 128. So 3 to the power of what gives me 128? Now we need to figure that out. Okay? This is why it's prolonging things. Yeah. And then, so it's without the calculator thing is what's annoying. Okay? But 3 to the power of...
3 to the power of 4 is 81 and 3 to the
Yeah, is 243. This actually has made it way more difficult. Way more difficult. Let's go backwards. I'm so sorry. You'd use the change of base if we didn't have such... See, these numbers are nice. I have the base and I have the value. Okay? Now, what we're going to do is the exact same thing. 2 to the power of what gives me 128?
It's 4.42.
Yeah, it's not nice. 2 to the power of... What's 2 to the power of 5? You know this. 2 to the power of 5. 32. 2 to the power of 6. 64. 2 to the power of 7. 128. So 2 to the power of 7 is 128. So what's the answer to this? 7. Very good. 7 is my answer to that. Okay? Now,
Would you just know what you're trying to learn and just like that?
yeah. It's never going to come up like this. Okay? We'll have x's in there. These two are the same base, and I'm minusing them. So I'm going to divide, exactly. Log to the base 3 of 45 over 5. Log to the base 3 of, what's 45 over 5? 9. Now, 3 to the power of what gives you 9? 2. 3 squared gives you your 9. Okay, so these are just little asides. 3 squared gives you 9. So my answer to this is 2. Because when you do a log, you get the power. So what's 7 plus 2? It's 9. Yeah, making it way more confusing, changing the base. I suppose I'll do...
Could you just find the number of log 3 to 45 and then
So 3 to the power of something won't give me 45 because it's not going to be a nice easy one.
Yeah.
Do you see the issue there? But this one was a nice easy one. 2 to the power of something gave me 128. Yeah.
How do you get the log 3 9 to get to 2?
How do I do this?
Yeah.
So basically you're saying log to the base 3 of 9 is x.
Yeah.
3 to the power of x is 9. 3 to the power of x is 3 to the power of, what's 9? 3 to the power of? 2. So then x is 2. So that's how I did that there. Okay?
So you don't have to write that out?
No, this is really just getting you to play around with all the laws. Okay? So they ask us to solve stuff in a little bit. Okay. I think that's enough.